Morning, all of you. Hello, friends. So, I will discuss today gaseous state some MCQ question. Okay. In the previous video, I will discuss about all concept of this chapter, and in the PGT chemistry syllabus, these all topics are included. Okay. Uh, in this is the syllabus of JSSC PGT chemistry, but WBSLST also these topics are included. Okay. So, the topics are, I will repeat it, postulates of kinetic theory of gases, deviation from ideal behavior of Van der Waals equation of state, critical temperature and pressure. These all terms are very important. Liquefaction of gas, this is very important, and critical constant and Van der Waals constant. The Van der Waals constant, that is A and B units and dimensions, are also very important. Molecular velocities, that is RMS velocities, average velocity, most probable velocity. These equations are very important for this exam, and Maxwell distribution of molecular velocities. Okay, so MCQs are, let's see. First question is, a gas from 27 degrees centigrade is heated up to 927 degrees centigrade, then its average velocity is. Okay, so for this you have to remember the formula of average velocity. Okay, so V average is equal to root over 8 RT by pi m. Okay, so for case 1, that is 27 degree centigrade, T is equal to 300 Kelvin. So I will put the value, and V average 1 is equal to this. Okay, in case of 927 degree centigrade, that is 1200 Kelvin, average velocity is this. Okay, but you can also solve this problem by this. Okay, this proportional to T. Okay, so V average 1 by V average 2 is equal to root over T1 by T2. You can also solve by this equation. This is easily solved. Okay, so this is V average 1, V average 2 is equal to 2 into V average 1. Okay, so this is doubled. Okay, at first you can solve by yourself, then if you can't, you see the solved paper. Okay, next question, write increasing order of root mean square speed of H2O2, CO2 and HBr. So root mean square, that is VRMS, the formula is equal to root over 3 RT by MW, that is molecular weight of the gas. Okay, so V RMS is proportional to root over 1 by MW, that is molecular weight. So if the molecular weight increases, then V RMS is decreases. Okay, so here increasing order so for HBr, the molecular weight is very high, then CO2, then O2, then H2. Okay, so in this case that HBr have lower VRMS. So the order is HBr less than CO2, less than O2, less than H2. As the question asked increasing order, so the order is that. Okay. Next question, at what temperature RMS speed of methane is same as that of oxygen at 300 Kelvin. Okay. So here VRMS of CH4 is equal to VRMS of O2, oxygen gas. This is equal for what temperature of CH4. Okay, so the formula of VRMS is equal to root over 3 RT by MW of CH4 is equal to root over 3 RT by MW of O2. Okay, so here T by 16 molecular weight of CH4, that is CH4 carbon, for carbon 12 and for 4 hydrogen 4. Okay, so 16. Next for O2, that is 32. Okay, so root over T by 16 is equal to root over T by 32, that is if we solve this, then T is equal to 150 Kelvin. So for 150 Kelvin temperature of CH4, the oxygen gas and CH4 gas will have the same RMS, VRMS. Okay. Next question. At constant pressure, root mean square speed of a gas varies with density as. So this is very important. You have to transfer all the topics that PV is equal to nRT. At first you have to write the VRMS, or you can write root over 3 RT by M. Okay, so 3 RT by M, this RT by M you can replace by D, either D or D inverse or D to the power half or D to the power minus half. Okay, so we know that PV from ideal gas equation, PV is equal to nRT, or PV is equal to N is equal to number of moles is equal to weight by molecular weight, given weight by molecular weight W by M RT, or P M you can rearrange PM is equal to W by V RT. Okay, we know that D is equal to density is equal to mass by volume, so PM is equal to DRT. So P by D is equal to RT by M. Now you can put RT by M value from this equation. Okay, so P by D. Now VRMS is proportional to root over 1 by D. So D to the power minus half. Okay, next question. Which of the following gas can be liquefied easily? We know that in the previous video I will discuss all the liquefaction reason or liquefaction condition, that is polar for polar molecule and for non-polar molecule. That is, for polar molecule force of attraction will increases and liquefaction increases. Okay, and for non-polar molecule, molecular weight is increases with the increasing of liquefaction. Okay, so here for NH3 molecule, this is polar molecule, so hence it is liquefied easily. Next, which of the following terms represent correction factor of pressure? Okay, so in Van der Waals equation, that is the correction term of pressure is equal to P plus A by V square. Okay, you can write P plus A by V square, Van der Waals equation, V minus B is equal to RT. Okay, so this is correction term of pressure, this is correction term of volume. Okay, so here we can as their option is given, option is this, so A by V square is the correction term. So P plus A by V square is the correction term of pressure. Okay, and you can also need to remember critical temperature, pressure and volume. And another question is for what temperature and pressure the gas can be liquefied, or ideal gas behave as real gas. Okay, so these are the very important topics. So thank you.